this lesson. This is Unit 1, Lesson 1 in Algebra 1B Part 2. Quadratic graphs and their properties. So we're going to look at some of the main ideas. You'll get more details in the lesson, of course. But this is kind of by way of introduction and helping to emphasize what you need to get out of the lesson. Okay? And plus you get my individual take on the concept. So we're graphing something called a quadratic equation, a quadratic function. Quadratic function. Okay? Quadratic functions are a whole class of functions built on this basic foundation, y equals x squared. So y equals x squared means take every input value x and multiply it by itself. Let's create a table here to generate what I'm talking about. So I'm going to give some x values. We're going to start with -3, -2, -1, 0, 1, 2, and 3. And we're going to have some y values. Okay? And this is known as creating a t-table. A t-table is a technique you can use to graph any function. But we're only going to use the t-table as an intermediate measure here to graph it, and then we'll hopefully notice some patterns so we can quickly sketch the graph of y equals x squared at any time. So y equals x squared means we take whatever x is and we multiply it by itself. -3 squared means -3 times -3. -3 times -3. A negative times a negative is a positive. 3 times 3 is 9. Then -2 squared means -2 times -2. -2 times -2 is positive 4. -1 squared means -1 times -1, which is positive 1. 0 squared means 0 times 0, which is 0. 1 squared means 1 times 1, which is 1. 2 squared means 2 times 2, which is 4. 3 squared means 3 times 3, which is 9. Now, hopefully you already notice the -3 and the positive 3 have the same answer. And the -2 and the positive 2 have the same answer. And the -1 and the positive 1 have the same answer. And that is actually by design. A negative times a negative number squared is always a positive number. And so that's important to remember. That's what creates the graph shape that we get that's kind of unique to quadratics. So let's go ahead and graph it. Graph it here. So we have -3, 9, 2, 4, 6, 8, 9. -2, 2, 4. -1, 1. 0, 0, 1, 1. 2, 4, and 3, 9. And notice the shape we get is it's a characteristic U-type shape. Okay, and the name of the shape is a parabola. It's not a V. It doesn't actually come to a sharp point. It's a smooth curve called a parabola. And the important numbers to note are 1, 1, 2, 4, and 3, 9, and -1, 1, -2, 4, -3, 9. Okay, and all other function variations on this are all the other formulas for quadratics are built on this basic function. We're going to explore that for several lessons here. So to begin with, I'm going to pull up Desmos, and we're going to experiment with Desmos. Desmos is our official calculator for this course. And you'll notice in Desmos we have a formula entry area and a graph area. You can actually put in formulas. You can put in notes, tables, folders, and images in this box. But I'm going to use it to enter y equals x squared. Now to get a squared, there's a couple of ways. You can click on the keyboard and choose a squared. Okay. However, it's faster to type the caret key on your computer keyboard. That's the one above the 6, Shift 6, that looks like the roof of a house. Okay, and that's the exponent button. By the way, on a test or a quiz, it is perfectly acceptable to type y or x, y equals x caret 2 when you mean y equals x squared. Okay, that caret means exponent. And yes, that is the name of the character. It's called a caret key, right? Exponent. So that's a good thing to know. And now look at our Desmos graph. It matches what we were talking about earlier. 1, 1, 2, 4, and 3, 9. Negative 1, 1, negative 2, 4, negative 3, 9. Okay? And so we want to examine what happens when I put a multiplier in front of it. So I'm going to leave the original in there. I'm going to say y equals 2x squared. Okay, and you'll notice what happens is the graph actually gets narrower, and we're going to spend quite a bit of time getting into detail why it behaves the way it does. Basically what's happening here is when you multiply by 2, you are making it twice as tall. Now it looks narrower. What it actually is taller, right? So if you had a 200-pound man, two 200-pound men, and one 200-pound man was 4 feet tall, and the other 200-pound man was 7 feet tall, who would look skinnier? Obviously the 200-pound 7-foot man, because he's much taller, and to be 200 pounds he's going to have to be considerably skinnier than the 4-foot man, which would be way overweight at 200 pounds for 4 feet high. Okay, and so it makes it taller. Everything's twice as tall. 0, 0, and instead of 1, 1, it's going to be 1, 2. Instead of 2, 4, it's going to be 2, 8, right? And so on. Instead of negative 2, 4, it's going to be negative 2, 8. Instead of negative 1, 1, it's going to be negative 1, 2. Everything is twice as high. All the y values are multiplied by 2. Okay. Now what happens when I replace the 2 with a 1/2? Okay. Now you'll notice it's wider, but in reality what it is, it's half as tall, right? Everything is half as tall. So everything is half as tall, and now it is, instead of over 1 up 1, it's going to be over 1 and up a half. Over 1 and up a half. Over 2 and up 4 becomes over 2 and up 2. Over 3 and up 9 becomes over 3 and up 4.5. Over 3 and up 4.5. Everything is half as tall. Okay? And then one more thing we can do. We can put a negative in front. And notice what a negative does. It takes what was upright and flips it down so it's upside down. And everything, all the y values, instead of going up, are now going down the same amount. And we can combine that. If I put negative 2, it's now taller, but it's upside down. It's twice as tall, but upside down. Okay? And one of the cool things about Desmos is I can do this. I can say, I'm going to put A in here, and I'm going to add a slider for A. As A gets bigger and bigger, so 4, 5, 6, it gets taller and taller and taller and taller, and hence looks skinnier. It's now 10 times as tall. Instead of over 1 up 1, it's over 1 up 10. Okay, as it goes down, it gets wider and wider because it's getting shorter and shorter. Shorter and shorter, 0.3, right, 0.1. 0.1 means everything is 1/10 as high. Okay, when it's 0, we get a flat line, and when it's negative, it goes upside down. Okay, and the further we go negative, the skinnier it gets because the taller it gets. Okay, so this, you can see, you can generate all kinds of parabolas, and you can make it like a bird flapping its wings. That's kind of fun. So feel free to play with this entering an A for a coefficient in Desmos. It's a lot of fun. It'll ask you right off if you want to add a slider. Okay. So now there's one more thing we want to change here, and that is I'd like to add something here. What if I start with x squared? X squared. What if I start with y equals x squared, and now I'm going to do the same thing, y equals x squared, but I'm going to add 2. Okay. You notice what's happened now. It's actually it's an optical illusion. It actually looks fatter. It's not. It's actually the same shape. The shape has not changed. It's simply everything has been shifted up. Everything has been slid up to, instead of going through at 0, 0, it's going through at 0, 2. Okay? It's going through 2 higher. Everything is 2 higher. Instead of 0, 1 or 1, 1, 1, 1, it's over 1, it's at 1, 3. It's 2 higher. Okay? All right? And you can imagine if I make it 3, everything is shifted up 3, 4. What if I subtract 1, right? Then everything is shifted down lower, lower. So let's do this. Let's do plus A. And you can see as A moves up, it goes up. As A gets smaller, it goes down until we reach 0 when it's the same shape. And then when it's negative, it's going down, but it's not flipped. It doesn't, this number doesn't flip it. Okay? All right? Now, what's really cool is we can combine this. So we can say y equals ax squared plus b, right? I'm going to add a slider for both, right? So when a is 0, when a gets bigger, it gets taller and skinnier because it's being multiplied. When a goes negative, it flips upside down, so we have the flapping bird. Okay? And when b gets bigger, the whole thing moves up. When b gets smaller, the whole thing moves down. Okay, let's go with a negative coefficient on the x squared, and we can move the whole thing up, whole thing down. Okay, one more example here. So here's how I kind of think it through in terms of my work here if I had to do it by hand. Let's say I have got y equals 2x squared minus 3. 2x squared minus 3. Now I could make a t-table, but let's start with the graph of y equals x squared. Remember our special numbers: 1, 0, 1, 4, 9. 0, 1, 4, 9. This is the graph of y equals x squared. Okay? The 2x squared is going to make everything twice as tall. 0 twice as tall as 0, 1 twice as tall as 2, 4 twice as tall as 8, and 9 twice as tall is 18, which goes off the page. All right, so we're just going to do it this way here. Okay, so the green represents y equals 2x squared. Everything is now twice as tall. Notice how it makes the dot skinnier because it's taller. Okay, and now the minus 3 moves it down. So let's go minus 3. Everything goes 3 lower. So 0 goes 1, 2, 3 down. 1 goes 1, 2, or 2 goes 3 down. Okay, this one goes 1, 2, 3 down. 1, 2, 3 down. Okay, and 1, 2, 3 down. So the blue graph represents the graph of y equals 2x squared minus 3. So that's kind of the way I process it. Let's verify with Desmos here. Verify with Desmos. Always use Desmos. You can use a calculator on any test question, any quiz question. Y equals 2x squared minus 3. I got an extra there. X squared minus 3. There we go. All right. And you can see from our graph here, from our green graph here, that it seems to match. It goes through at 0, 3. It goes 0, negative 3. Goes through about a little over 1, right? That's right here, the y. That's called the x-intercept. Okay, but it goes through the point negative 1, negative 1, right? 1, negative 1, and so on. So hopefully that helps. You'll get a lot more details in the lesson itself, of course, but this is meant to help give you a highlight of the topics. All right. Feel free to book a live lesson if you need help.